Hello everyone. So today in this video, what I would like to discuss is how we can give configuration or designation to the various stereoisomers. So in the previous videos, we have been looking into how to draw, how to identify whether a molecule is optically active and how to identify the molecule presence of chiral center in a molecule, and also how to draw them on a two-dimension using a Fisher projection and a perspective formula. So to understand what I am telling right now about the configuration or the designation of stereoisomers, probably you won't be understanding what I'm trying to tell you. So let me take an example to illustrate this particular point to you. For example, if we talk about a simple molecule like glyceraldehyde. So if we look at this molecule that is glyceraldehyde, which is a simplest carbohydrate with a 3-carbon atom. Okay, so this is the Fisher projection formula for a simple glyceraldehyde molecule. So, and this is the corresponding Fisher projection perspective formula of this particular Fisher projection formula of the glyceraldehyde. And this particular structure here is the mirror image of this particular structure, and this is the corresponding perspective formula for this particular Fisher projection formula of the glyceraldehyde. Now, on structural basis, when I draw these two isomers, I can easily say that, okay, this has a chiral center, this second molecule also has a chiral center, and therefore these two, these represent optically active molecule. Now, if I ask you, what is the name of this particular isomer and what is the name of this particular isomer, you would be finding it difficult how to name them, because both of them would be named as what? Simply glyceraldehyde. How you're going to distinguish between this isomer and this isomer. Okay? So that's why we require a certain system of nomenclature to name these stereo isomers. Okay, so that is what we are going to study in this particular video in a very brief sense, because I'm going to discuss more about how to use in order to apply them properly in the next videos. But just to give a glimpse of the various nomenclature used, I'm going to use this particular video. So as you can see, as I have written down here, there are two types of nomenclature written down here. One is the DL system of the nomenclature. Here it is capital D and capital N. So it is the DL system of nomenclature. It's a very old format of nomenclature that was used previously in order to identify stereoisomers, because initially these kind of optical activity was prevalent in carbohydrate molecule. So Fisher, being one who was very pioneering, who had done very pioneering work in carbohydrates, developed this type of nomenclature. And this is an older system of nomenclature which now is not used so much. It's only now limited to the being used in carbohydrate chemistry. So probably I don't know whether you have still learned about carbohydrates. When you're going to learn about carbohydrates, there you will talk about this D and L configuration of carbohydrates. I'll discuss briefly about this particular nomenclature. Another type of nomenclature that is prevalent is the RS system of nomenclature, and this particular system is more newer, and it was developed by three scientists, Khan, Ingold, and Prelog. That's why the rules that were developed by this is called the CIP rules, which are actually used for naming the various stereoisomers. So we will be discussing more detail, more examples of this RS nomenclature in the coming videos, so you get exhaustively familiarized with these particular nomenclature. Okay, so let me briefly introduce what these are. Okay, so the first, that is the DL system of nomenclature. Okay, let me write down again that for you. A DL system of nomenclature. So in DL system of nomenclature, it is the basis for that nomenclature is nothing but the Fisher projection formulas. Okay, so basically in this, what you do is you will write a particular molecule in the Fisher projection formula. What is the pattern in which you write them? You write the carbon chain in the vertical bond, and the substituents are arranged on the horizontal bond. So for example, this is the simplest carbohydrate, that is the glyceraldehyde. So here you can see the carbon chain 1, 2, and 3. So it's in the vertical chain. The substituent H and OH are written on the horizontal bond. Now, another important thing that you make sure while using this nomenclature is that you will place the highly oxidized carbon or the first carbon on the top. Okay, and then you write it on the vertical chain, and then you arrange the substituent. Now, after writing the substituent, if the OH group on the chiral center is on the right side, we say that particular, like in this case, the OH is on the right side, we say it to be D-glyceraldehyde. Okay, this is D-glyceraldehyde. Okay, similarly, in this particular case, the mirror image, OH is on the left side, so it is called as the L-glyceraldehyde. Okay, this is a very old system of nomenclature. So for example, I'll go to a little bit complex. So for example, glucose. Okay, so if I write glucose, glucose is a 6-membered chain. So you have the CHO group on the top, and then if you write it in the form of Fisher projection, it's a 6-membered ring. So 1, 2, 3, 4, 5, 6. So it's glucose is 6-member molecule. So I've written the whole carbon chain on the vertical chain. Substituents now I'm going to write here. Okay, so it's basically CHOH, OHH, okay, HOH, and HOH. Okay, so this is much more complex. So here now you will ask me how we will decide. Okay, here what you do is the last chiral center. Okay, this is the last chiral center in this particular molecule. We will decide D and L based on this. So if on the last chiral center, if OH is on the right side, we say this to be D-glucose. So this is the D-glucose. Now, if you draw the mirror image of this particular molecule, go ahead and draw that yourself. You'll find that this OH is on the right side. So the mirror image would be nothing but your L-glucose molecule. Okay. So this is a very old format of nomenclature. Now, this particular thing works very easily for the carbohydrates, but when it comes to various other molecules which are not related to carbohydrates, it was very difficult to be used. Initially, it was said that those compounds, if we are able to synthesize from the D-glyceraldehyde, those optical isomers would be called as D. And if we are able to synthesize certain molecules from the L-glyceraldehyde, we will say that configuration of that particular new optical isomers to be L form. But that particular way of doing the nomenclature for other optical isomers was pretty difficult. That's why it was kind of not used later on and replaced by another system of nomenclature called the RS system of nomenclature. So this system of nomenclature, you will even look at it more when you go to study about the carbohydrate chemistry. Now let us point out to the most prevalent type of nomenclature, and that is nothing but your RS system of nomenclature. So what you do in an RS system of nomenclature. So I just a simple illustration. So if I write suppose a molecule is made up of a chiral center, and I draw the Fisher projection formula, and I have 4 different substituents that are arranged on these 4 bonds. Okay, and I talk about the priorities. Now, priorities are based upon the atomic numbers. So it's not clear here. It's the priorities in this particular nomenclature is based on the atomic number. So if according to atomic number, the highest atomic number would be getting the first priority, then the second priority, then the third priority, then the fourth priority. So the priorities are written on the basis of the highest atomic number is going to get the first priority, then the next, and then the fourth one. So fourth one would be this I have written randomly as 1, 2, 3, 4. It all depends upon which groups are there. Okay, which I will be discussing in the next video by talking about the example. So here you can see the fourth group. Okay, what I make sure while using this particular system of nomenclature is that my fourth group is behind the plane of this particular page. Okay, so as you know, in a Fisher projection formula, the vertical bonds represent bonds that are directed inwards. Okay, so that we know. So in this, when I try to prioritize the different groups attached to this chiral center, I find that this fourth group is on the bond that is behind. Okay, so when my Fisher projection is in this particular format, and then I try to move from 1 to 2, 2 to 3, if it is going in a clockwise fashion, I say that to be a R configuration. Okay, and suppose I have the groups attached in this particular way, and my fourth group is here. Okay, then when I move from 1 to 2, 2 to 3, it is an anti-clockwise. So I say this particular isomer to be the S isomer. Okay, suppose another way of doing it. Suppose I have, when I prioritize the group, I get something like this: 2, 4, and 3, something like this. Okay. So now if you see, this fourth group is on the bond that is towards you, that is above the plane. Okay. So now, when we decide the RS nomenclature, it is important to know that the fourth group should be on the vertical bond. Only then it will be behind. Okay. So if you have the fourth group on the bond that is towards you, then what you have to remember is when you move from 1 to 2, 2 to 3, and 3 to 1. Okay, basically 1 to 2 to 3. When you do it, it is a clockwise motion. Okay, but since your fourth group is on the bond that is on the horizontal bond which is towards you, whatever configuration you get here is the opposite. Okay, so here according to this configuration, it is a clockwise manner. Okay, no, it's an anti-clockwise manner. So it's a S configuration that comes from this particular rotation. But since fourth group is on the bond that is on the horizontal bond, therefore the configuration of this particular molecule would be nothing but R, that is opposite of what you originally see. Okay. Similarly, you can do this in the perspective formula as well. Suppose you have your perspective formula something like this, and you have your priorities 1, 2, 3, and 4. Okay. Now the fourth group is on the behind the bond. So when you move from 1 to 2 to 3, it's a kind of clockwise motion. This particular isomer would be nothing but R isomer. Okay. Suppose your priority group is something like this. Suppose you arrange the priorities. Okay. And then you get priority something like this: 1, 2. You get the 3 here, and you get the 4 here. Okay. Now fourth group is on the bond that is towards you. Okay. So now when you move from 1 to 2 to 3, okay, it comes out to be clockwise. So you tend to think that it is R, but no, because 4 is on the group towards you. Okay. Therefore, whatever configuration you get, it's the opposite. So in this case, it is the S isomer. Okay. So that is how we use this particular nomenclature. So we will look into the real examples, like we were going to discuss about how to name this glyceraldehyde. From that, we will come to know how to use them in real scenarios. So basically, you understood that RS system of nomenclature can be used both on Fisher and the perspective formula. Only thing is the Fisher projection formula and the perspective formula, you have to make sure that your fourth priority group is on the behind the plane of the writing, or behind the writing plane. If it is towards you, that means above the writing plane, and whatever the configuration you are getting, it's the opposite. So when you move from 1 to 2 to 3, it's clockwise, then you say it to be the R isomer. And when you move from 1 to 2 to 3, And if it is anti-clockwise, you say it to be the S isomer. This is the case when your fourth priority group is behind the writing plane. And if it is above the writing plane, and when you move from 1 to 2 to 3, it is R, then the actual configuration is nothing but S. And if it is 1 to 2 to 3, it's S, and your group is above the plane, then we have the opposite configuration, that is the R. I hope you understood what I just now discussed with you. We will discuss in the coming video with more real examples to know more about how to use this particular RS system of nomenclature. Thank you very much for your attention.